Counting on you. All right, the last one is definitely a tricky problem. What vertical distance does the car fall between 1/2 and 1 second? Definitely a tricky problem. And actually this one was on a Regents, and it was one of those 99 makers. It was kind of meant to give you stress. So, even though you see the word vertical here, is this a curved trajectory? Yes. That means make the chart. X, Y, R. Oh boy, we know a lot of stuff now. A lot of stuff now. Probably a good time to pause the video, you fill in your givens, and then come back and see and play it, see that we coordinate. So, acceleration in the X. That means you, there, watching at home. Pause, do it yourself. Then, when you're done, come back and check. Down is positive. Acceleration 9.81. Resultant of 0 and 9.81 down is 9.81 down. We know our VI in the X is 15. We know our VI in the Y is 0. The resultant of the two is 15 meters per second. Okay, what else do we know? Well, we knew a bunch of stuff about the end. The interesting thing here, we can put our VF in here too. The interesting thing here is realizing, before we go and fill in the rest of our givens, realizing, I'm doing a video. Thank you, Realize, don't hit it though.
Dang it.
Realizing that, it's alright, they'll appreciate it.
How close are you going to see that?
Realizing that, good job man, that your VF at the end, your D at the end, your T at the end no longer apply because we are talking about between 1/2 and 1 second. So there's a couple of ways to approach this problem. Probably the simplest way, the brute force method to approach this problem is to figure out the distance at 1/2 second, the distance at 1 second, and subtract the two. So if you imagine that visually, here's your trajectory. Don't bump that.
Don't bump the camera.
Visually,
Yeah,
here's your trajectory, and
who's he doing this for?
after 1 second, later, Hoss.
Oh, so you'll stop for him. I can't ask you one question.
Your question's gonna take 2 minutes.
No, it's 5 seconds. Would you
After
count it
1
as substitution? Would you count it as substitution?
Pause.
Pause. Would you count that as substitution?
With
A
units?
squared plus B squared plus C squared.
As givens?
Yeah.
Yeah.
Okay. Because you didn't
Definitely.
label A, B, and C. Okay, that sounds good.
You didn't label A, B, and C. Alright, so after one, don't touch it, it's gonna fall off.
You're not in the video.
It doesn't matter. I don't need to be in the video over here. They can hear me. After 1 second, it'll be here. After 2 seconds, it'll be, let's say, here. And so the question is asking how much vertical distance, or excuse me, 1 second. Thank you, Mr. Group, you're messing me up. Let's make it a little closer. 1/2 second and 1 second. So after 1/2 second, the car has fallen vertically this much. And after a full second, the car has fallen vertically
That much.
this full distance. So really, what is the question asking for? The question wants to know about this distance here, between 1/2 second and 1 second, which is a challenging problem. But the brute force simplest way to go about it is first to solve that little green line. First to solve for the y displacement, so dy at 1/2 second is what we want, and of course the time that would go with 1/2 second is, of course, 1/2 second.
Hey, burps.
And so, hello. And so, at this point, you can solve for your dy. Can you please get out of the video?
People keep bugging you, man.
Dude,
Wait,
I
Bert,
hate
I have
all
a
of you.
question.
I don't
I
care.
have a question.
Yeah, someone who cares. Okay, now, solving this one for the dy, d equals VIT plus 1/2 AT squared. You can solve this little piece. That's the green segment. D equals VIT plus 1/2 AT squared. This one is actually nicer. The VI is 0.
Dr. Capuano, if you're anywhere in the building, please call Anna DeLeggy. Thank you.
Make sure if you see Dr. Capuano, you tell him this goes away. 1/2, 9.81 times 0.5 seconds squared. Okay. Pete, run the calculation for us.
Yes, sir.
This is going to be 1/8 of not do 9.81 divide 8. And so dy at 1/2 second will be.
You said 9.81 divided 8.
Yes, I did.
Okay, I got 1.226.
Good. So up 1.23 meters. So at, and now write this, at 1/2 second in, our displacement in the y is 1.23 meters. Now we have to find this orange displacement. As it turns out, more than one way to skin this cat. You now have a number of options you can follow through here. We're going to pick one. Feel free to try others. We want to find dy at 1 second. That's 1.0. We know the time at 1 second, of course, is 1 second. And we run through and do the same calculation again. I'll run straight to the substituted. VI t plus 1/2 a t squared. Pete, I don't need you for this one because 1 squared is 1. 1/2 of 9.81 is 4.91 meters, roughly. 4.91 meters. And so finally, to find the pink, you're actually subtracting the full 1 second minus the 1/2 second. So from 1/2 second to 1 second is going to be a subtraction. Good Lord. 4.91 minus 1.23. Let's see. That's an 8. That's a 6. That's a 3. There's your answer. 3.7 meters. Now, yeah, please. There are other ways you could have approached this too. For some of you that are more reflective about your velocities in the time, you may have actually preferred to think about what is the initial velocity in the y at 1/2 second, and then solve for d over the next 1/2 second. And so what I mean by that, I'm going to extend our y column over here. You may have said, wait a minute, I know that the acceleration in the y is 9.81 per second. Speeds up by 9.81 or changes velocity each second. So at 1/2 second, it's going only halfway up to that. You could have said, oh, well, I'm going to do this set again. A is 9.81. My VI at 1/2 second is 4.91, also downward. Meter per second squared, meter per second. The time it takes to go from 1/2 to 1 second is 1/2 second. And the D I cover during that time interval from 1/2 to 1 is what I'm trying to find. And so you could have done it this way. Again, D is VI. This time it would have been 4.91 times T plus 1/2 A T squared. And you can see for yourself that this also would come out to our 3.68. Basically, half of 4.9, you get about 2.45, plus the same, this term here is what we did before, 1.23. So if you're looking at about 3.5 and 1.2, or sorry, excuse me, 2.5 and 1.2, you get your 3.7 again. It works. All right. This one is definitely a pump your feet, so is the last one. I made these two particularly difficult. They're not standard test level. 25, 26 were tough questions.